Okay, this week I'm going to do problem number 23 from your textbook for you. It comes along with this graph of velocity versus time. My graph is a little different than yours because I counted by ones for time. Whoops. And it asks you what is the apparent weight at time equals 1 second, 5 seconds, and 9 seconds. So apparent weight is another way of talking about your normal. It's how heavy you feel. So time equals 1 second here. I can look at my graph and it's in that first portion of the graph where the line is sloping up. So if I look at my graph, I can see velocity is going up. Acceleration is positive, so it's going up. They all agree. I can easily find the acceleration by finding the slope of the line. So slope equals rise over run. So I've got 8 minus 0 over 2 minus 0, or 4 meters per second squared. So if you think about your guy in the elevator, right, here's my elevator, guy in elevator. Okay. So the guy, right, is experiencing some gravity, and he's got a responsive normal. But now your whole elevator is accelerating upward with some kind of a force. It's actually a tension for the elevator. Well, let's just call it force elevator, F sub E, which is accelerating up, and that contributes to the push on this guy's feet. The push on the feet is your apparent weight. That is your normal force. So we actually need to add that F of E in there to the normal as well. So F sub N is going to be the sum of F sub G and F sub E. We would actually need to take the absolute value of F sub G in this case because we know that the normal is going to be equal but opposite. So let's look back at time equals 1 second. So I want to know my normal force. I want to know that apparent weight. So the absolute value of F of G is his mass, 75 kilograms, times gravity of 9.8 meters per second squared. And the elevator, he still has 75 kilograms, and the elevator has an acceleration that we found of 4 meters per second squared. So let's calculate. So 75 times 9.8 plus 75 times 4. And I get 1,035 newtons. So far, so good. So now I want to know about time equals 5 seconds. So if I look at back at my graph, I look at 5 seconds, I can see that my velocity versus time graph is flat at that point. So the slope of that flat line is 0. So that means my acceleration of the elevator is 0. So in my equation that I found, normal force is equal to absolute gravity plus elevator. If the acceleration of my elevator is 0, this whole term goes away. So I'm just finding the absolute value of my gravitational force. So that's 75 kilograms times 9.8 meters per second squared. And I get 735 newtons. In the last piece of my question, it's asking me about time equals 9 seconds. So now I can look at my graph and I can see that even though the velocity is still positive, the acceleration, the slope of my line is now definitely negative. So I'm going to start by finding the slope of the line. So slope is rise over run. So I've got 8 minus 0 over 10 minus 6. So that is 8 over 4, or 2. It's important to note here that it's going to be a negative 2 meters per second squared because the line is sloping down. I should have done a 0 minus 8, I guess, on the top. All right, so now I'm just going to do the same thing I have been. So my normal force and my apparent weight is equal to absolute gravity plus the acceleration of the elevator. So I've got 75 times 9.8 meters per second squared plus 75 kilograms times negative 2 meters per second squared. So that's going to end up subtracting, right, with the negative 2. So 75 times 9.8 plus 75 times -2 gives me 585 newtons. So just like we expected with our eyes closed, we're thinking about going up in an elevator. You feel heavier at first when it starts to accelerate up. You feel pretty normal when it's going at a constant speed. And then you get to feel pretty light for a second right before it stops.